Okay, we're looking at number 42 from 2-7. This is a wonderful scenario. We got a jumping cricket. This equation was given to me. In fact, everything that I'm writing here, I'll highlight a line here in green. Everything above this green highlighted line was part of the setup of the problem. It was given to us. We didn't have to come up with this. We're told there's a jumping cricket. We're told that this equation, y is equal to negative 16t squared plus 8t, models the height of the cricket in feet as time passes in seconds. So we know what y stands for. The y value is the height, right, in feet. And then the t value, which we see here and we see here, that's our time in seconds. And then we're asked this question, after how many seconds is the grasshopper 1 foot off the ground? Oh, it looks like I changed it from cricket to grasshopper. I don't think those things are actually interchangeable, but that's okay. For the sake of this problem, I might call it a cricket. I might call it a grasshopper. The bug. After how many seconds is the bug 1 foot off the ground? So this is where you actually now need to start making some deductions. 1 foot off the ground. Well, which variable is measuring height? Well, that's the y variable. They want it 1 foot off the ground. So we want our y value to be 1. You are going to take the given equation and you are going to replace y with the number 1. So we end up here. 1 is equal to negative 16t squared plus 8t. Now, for us, this is a quadratic, and I know it's a quadratic because I got a t squared, I got a t. In this whole chapter, this whole section, we have been solving by getting an equation where we have set it equal to 0 and factoring. So that's what we have to do here. The very first thing you have to do is subtract 1 from both sides, and I'll kind of write it over here, only because it's not a like term. It's a constant. It's just a number, and this is a t squared term, and this is a t term. So this guy will be on its own. We'll end up getting something that looks like this. And actually, at this point, it should look pretty familiar. This is the type of problems that we have been solving. We need to factor. We need to create a multiplication problem, because if a multiplication problem equals 0, then one of those two things equals 0. So that's my goal moving forward, is that I'm going to factor this guy. And this happens to be from the section of a perfect square trinomial, from a special pattern one. But I'm going to go ahead and just factor it kind of like normal. I'll come back up to here. I'm just going to rewrite the equation down here. 0 is equal to negative 16t squared plus 8t minus 1. Now, another thing that we've talked about is that we don't like having our first term being negative. So I'm actually going to divide every single term by a negative 1. That will end up flipping the signs for us. For the sake of solving this equation, it's not going to change the answers at all. What I'm doing is mathematically legal. It just makes factoring easier. We're going to have 16t squared minus 8t plus 1. Okay, so let's see. From here, I'm going to set up my area model. I'm going to get 16t squared here. I'm going to get 1 there. I need to set up a diamond problem for me to figure out how to split up my negative 8. They need to add to negative 8, multiply to get 16. And the only way to do that is to do negative 4 and 4. So these two terms here become negative 4t and a negative 4t. Once I factor that, let's see, as I'm looking across 16t squared and a minus 4t, what goes into both of those is 4 and a t. And then the same thing on my column, 16t squared and minus 4t. So this will be minus 1. This will be minus 1, and the negative 1 times the negative 1 is 1. So this is what I'm looking for. I have now factored it. Right. I have 4t minus 1 times 4t minus 1. So if I go back to here, where I was looking to factor this, which, by the way, I might have been able to recognize because it is a perfect square trinomial, but that's okay. Minus 1 and 4t minus 1. So now what I can do is I can set each of these pieces equal to 0 and solve it. And since they're identical, I really only need to do this one time. I'm going to take my 4t minus 1 and set it equal to 0 and solve that. I'll add 1 to both sides. So I'm going to get 4t is equal to 1. I'll just rewrite it up here because I'm kind of running out of room a little bit. Divide both sides by 4. And I'm going to get t is 1/4 of a second. Or if I prefer, you wanted to plug that into the calculator to get your 1/4, 0.25, 0.25 seconds. That is my final answer. That answers the question, after how many seconds is the grasshopper 1 foot off the ground? And it's not very long, but it's reasonable. It makes sense to actually say here that it's not going to take very much time for a grasshopper or a cricket or whatever bug to jump 1 foot into the air. So 1/4 second is quite reasonable. That's my final answer, and I got there by setting my quadratic equal to 0, factoring, and solving. Hope that's helpful. Message me anytime with questions.